let's go. Let's look at chapter 20. Okay, so guys, for your info, this is when your honeymoon begins. Yeah, chapter 20, chapter 21 is very, very honeymoon, very easy chapter. Okay, first, let's look at delta H lattice. So again, delta H lattice, right, is when we are forming an ionic solid from an ions, energy is released. Yeah, so it's an exothermic reaction. So I can say that, right, the definition is the energy released. Okay, when 1 mole of ionic compound is formed from its gaseous ion. Under standard condition. Okay, so energy release, 1 mole of ionic compound is formed from its gaseous ion. Please remember that. Next, it is always exothermic, combining your ions. I remember that. Okay, and lattice energy is always negative because value of delta H is always exothermic. Okay, so the more, highlight the word, the more exothermic the value is, the stronger the ionic compound. Done? All right, guys, next. What are the factors affecting the value of lattice energy, right? You have 2 factors. The first one, right, is your ion size. Second one, we call it as nuclear charge. All right, guys, now let's look at my study tips. All right, guys, first part, I want you guys to prioritize, okay, the charges first before looking at the size of the ion. Okay, so guys, I can say, right, the greater the effective nuclear charge, so the higher okay, so the higher the effective nuclear charge, the more exothermic your delta H lattice are. Okay, so which is why, right, guys, if you look at Mg, it's definitely greater than your Mg is definitely greater than your Na, okay? Or your O2 minus is definitely greater than your F minus. And all right, guys, second factor, ion size. Kid, the bigger the ion size, how? The more or the less negative? The less negative is your delta H ladder. Done. Okay, because again, right, if you have a big ion, how? Okay, you have a big ion, what happened to the attraction? Is the attraction here strong or weak? Weak, right? Which means a weak ionic bond is formed, right? So which means it's easier. Okay, finish up. Give me a minute. I go washroom and water. Go, go, go. Give you guys about 1 minute break, 2 minutes break. Go. You see, okay, as the size of the ion increases, what happened to the lattice energy? Go. The lattice energy become. Okay, so again, guys, I don't want you guys to use the word increase or decrease. So try not to write increases and decreases here. I do not want it to be. Okay, because guys, again, negative 300 to negative 100, increase or decrease? You tell me now. Increase or decrease? Some people say increase. You are right, right? Okay, some people say decrease. Also, you are right. So again, guys, examiner will not mark because they do not know. Are you telling about the magnitude decreases or the overall value increases? So try not to write increase and decrease here, but to write it as more negative, less negative, more exo, less exo. So I want you guys to write it as less exothermic. Don't write increase and decrease. No. Okay, because the value has a sign, a negative sign. So don't write increase and decrease. So guys, again, I can say that the charge density decreases with the increasing ionic radius. Okay, why charge density decrease? Again, as you go across, okay, you see, if you have a bigger and bigger ionic radius, what happened to the charge density? What is charge density again? Should you remember what charge density is? It's the charge over the size, right? Do you see that? Negative 1, negative 1, negative 1. Everything is negative 1. But look at the size. Do you see that the size is bigger? So when the denominator is bigger, the charge density decreases, right? Get it? Can Come again, bigger ion. Okay, again, if you have a bigger ion, what will happen to the bond form? For example, I minus bond with CS plus. Is it weak bond or strong bond? Weaker, right? Because the attraction is weaker, right? Get it why? Yeah, it's far away from the nucleus, right? All right. So which is why when the attraction is weaker, then less exothermic. Understand? Or you see, the more exothermic it is, the stronger the bond, the stronger the ionic compound. So if you put a small one, you see that the attraction is very strong. All right. So you have a high value or more negative value. But if you have a big one, you see a weaker attraction, which means less exothermic. Because the bond is weaker. When a weak bond is formed, less energy is given out. When a strong bond is formed, a lot of energy is given out. All right, bond form, release energy. No, bond break is absorb energy. If you want to break a bond, absorbing energy. Break a bond, absorb, forms a bond, release. All right, guys, next. Charge on the ions. So, guys, the lattice energy becomes, you guys tell me the answer, as the ionic charge decreases. You have to tell me why also. Go. How? Cannot say decrease, increase. Why more negative? Okay, so again, to answer your question, ionic charge decreases, which means from 2 plus turn into 1 plus. So guys, what will happen to the ionic bond? Is it weaker or stronger? Weaker, right? When you have weaker ionic bond, more energy or less energy release? When you have less energy release, more exo or less exo? Thank you very much. Get it now. Don't memorize, try to understand it, yeah? Clear. Lovely. Sure. So again, you see, the value of MgO is way higher. LIF is 1000 plus, MgO is 4000 plus. You see, they have similar radius, similar size. Just that Mg2 plus and O2 minus attract each other more strongly. Why? Because high charge, right? So stronger bond is formed. Oh my God. We have ion polarization. Oh, Lawrence, what is this nonsense? Okay, so for ions polarization, right? Guys, you done ion polarization, you done it in school, right? Okay, so ion polarization, again, it contributes to covalency here. Which means, right, guys, when ion polarization occurs, you have some small extent of covalent bonding, of covalent property is shown. Understand? Okay, so it contributes to a covalency. So when ion polarization occur, okay, you see some covalent effect. Okay, some covalent property. Twenty, 21, 22, electrochem, 23, ionic equilibria, 24, group 2 done, 25, transition element done, 26, strict kinetics done. Okay, good. So we're almost there already. All right, guys, in some cases, the positive charge on the cation will attract the electrons from the anion. Okay, so again, don't care, guys, I'll give you a diagram. So, kid, you see, right, this is the difference between an ideal case and in actual. So, guys, in ideal case, right, okay, last time when we done it in IGCSE at A levels, right, AS, right. So, example, if I put Al3 plus like that, and O2 minus next to it, right? So I can visualize them as Al3 plus and O2 minus. So if you put it side by side, right? Okay, you have thought that they arrange like that. Okay, so, but this is not the case. Okay, so this is not the actual case. In actual case, right, it's not like that. So in actual case, right, you draw it out first, later I'll show you how it look like in actual. All right, guys, in actual, okay, it's not gonna be like that now. Okay, so I want you guys to draw your Al3 plus. Okay, and O2 minus, right? When you put it side by side to your when you put it side by side to your Al3 plus, right, guys, your O2 minus, okay, the electrons cloud in your O2 minus, right, will get dragged into the OH, into the O2 minus. Okay, so they will get dragged like that. So basically, they get dragged inside, and it does look something like that. So when this thing occur, right, this we call it as ion polarization. Okay, when this thing occur, we call it as ion polarization occur. Okay, when your cation is very small, okay, and having a very high charge, okay, and your anion is very big and is easily disrupted. So this we call it as ion polarization. Okay, don't worry, come, let me talk about it. So in order for ion polarization to occur, right, my cation, okay, must have a strong polarizing ability, understand? So to have a strong polarizing ability means the ability to pull the n electron cloud. Okay, to pull the anion electron cloud, that we call it as polarizing ability. So in order for them to have strong polarizing ability, their ionic radius must be small or big. So for example, if you put a fat dude here compared to a skinny dude, which one is having a stronger polarizing ability? Smaller one, right? Because it's closer to the nucleus, right? So you must have a small ionic radius, understand? Okay, next, let's look at the charge. Do you prefer it to be 1 plus or 3 plus? In order for you to pull it, do you prefer to be 1 plus or 3 plus? Yes, correct. Second one must be high charge. What on earth? You come 15 minutes before the class end? What the hell? Where were you? Valentine, right? Yeah. Oh, 4 months leave. No. What do you mean by this? Valentine's. This fella, come. We're finally getting an iPad.
What do you got, dude? Long time.
Oh, yeah. No, finally getting an pencil.
What do you have also?
Yeah, man.
Yeah. I buy next year. Wait, I don't know.
All right, guys, next. You see, the class 10 empty today.
Yeah, even Malcolm never come also. Probably with Shannon lah.
Probably dating. I like your pants.
Huh?
I like your pants. Uniqlo, right?
Yeah, Uniqlo.
I got the same one.
Right.
I got the same one.
It's
It's
damn
like,
nice,
yeah,
bro.
it's that nice.
But
It's that nice.
it's too, how to say?
Yeah.
Too stiff.
Too stiff. Yeah. All right, guys, next. Okay, let's look at your anion. So again, in order for your anion to be easily polarized, yeah. Nah, easy chapter. So again, I can say, right, the bigger the anion, then the easier it is to be polarized, right? Correct. Okay, so which means the electron cloud. Okay, so the electron cloud is distorted. Okay. Okay, electron cloud is distorted. So this is also known as a polarized anion. So guys, when anion is being polarized, right, the bond in the anion is weakened. Okay, so the bond in anion is weakened. That's it. Polarized means being pulled. Okay, polarized means pull. Nah, you don't need to define that. The definition is out of the syllabus.
Should I go to
Go back. Go home tonight. Because the positive charge on the cation will attract the electrons from the anion. So this result in the polarization of the anion electron cloud. Okay, the ability of the cation to pull the electrons towards itself is known as the polarizing power. Done. Electron cloud, this one, electron shower. Pull. Distorted means pull. The second, let me see my graphic. Electron affinity. What electron affinity is? So guys, electron affinity, right, we call it as the ability to receive electrons. Yeah? So it's just opposite of ionization energy. Okay, so guys, the first electron affinity, right, is the enthalpy change. When 1 mole of gaseous atom, okay, receives 1 mole of electron. Remember, yeah? Okay, to form 1 mole of gaseous 1 minus ion. Just spend your glasses, right? Oh my god, later you forget again. Oh, like last time. No, I mean like you spend an hour to travel here for a 15 minutes lesson.
I was in one day only.
Oh.
This one have too much calorie, man.
I did not mean prep today. So guys, you see that from gaseous, receive 1 electron, also into gaseous. Gaseous to gaseous. And guys, let's look at the value. I want you guys to write it down. Your first electron affinity is always exothermic. Yeah? This chapter is the easiest. So, okay, remember, yeah, guys, first EA is exothermic. All right, guys, next, highlight this second EA, highlight plus, and write it down as second EA onwards. It's gonna be endothermic now. Okay, guys, remember second EA onwards is endothermic. Yeah? You guys done right? Why? What's the reason? What's the reason? Why is it endothermic for second EA? Yes. How? Alright, guys, second EA are endothermic. What's the reason, guys? Okay, because you are adding electrons into an N-ion, right? N-ion is already negatively charged, right? It repel each other, am I right? So it will repel one another. So I can say that. What the hell? So guys, you see, right? Let's say if you want to add one more electron in, right? To turn it into a Cl2 minus, yeah. This is your second EA, right? Do you see that negative charge anion and negative electrons, they will repel one another. Understand? So they repel one another, which make it, okay, require energy to overcome the repulsive forces. Cook zero. So not healthy, right?
You believe in that shit, man?
I mean, that's the only energy is required to overcome the repulsive forces between anion and incoming electrons. Going down group 17. Okay, electrons affinity becomes less exothermic down the group. Guys, again, avoid using the word increase or decrease. Yeah, use more exo or less exo. Why? Reason being, atomic radius increases down the group. Attraction is weaker now. Done. Huh? Use the fellow one doctor then. Please like and subscribe. Someone can take it. Please like and subscribe.